Today we are going to see about Zigbee technologies. When you are designing, planning and prototyping a wireless application, the protocol you choose is a key component. Okay, with considerations for security, flexibility and the ability to deploy to the multiple regions. So now we are going to see about introduction to Zigbee technologies. So Zigbee is basically a wireless technology developed on an open global standard to address the unique needs of low cost, low power wireless IoT networks. So this Zigbee Alliance introduced the Zigbee technology and it was developed based on the standard group of solutions called layers. These design layers have furnished Zigbee with special features like affordable cost, also process the feature of reliability. So generally this ZB, as already said, it is a wireless technology and it runs on 802.15.4 physical radio specifications, which is based to build a ZB applied science and also IEEE based standard, which explains the features of physical layer and medium access control layer for wireless personal area networks. So this is also which is operated as stack operates gained ratification and the Institute of EEE, that means IEEE in 2003. The specification is a packet based radio protocol intended for a low cost and battery operated devices. This protocol allows devices to communicate in a variety of network topologies and can have a battery life lasting several years. So these are types of ZB technology devices. So generally ZB network consists of nodes and these nodes are called ZB devices, which consist of a single node, has a components like microcontroller, transistor, receiver, transceiver, etc. And also this node can function as a FFD, which is called as a full function device, and also RFD, reduced function device. And generally this is of two types. It is categorized into two, which is a physical type and then one is a logical type. These physical devices are further classified into, we have mentioned, no, FFD and then RFD. So consider any machine may act as a sensor node, control node and also composite machine without regret to each types. So the routing function of a network are done by the full function device depending on the position of full function devices in a network. And also the logical type of devices are classified into three types, which is called as a coordinator, router and also end device. Among these, which is mentioned, coordinator, router and end device. The coordinator is the most capable machine which plays the role of a root in a network tree. At the same time, these forms a bridge to the other networks. So coming to the router, um, it is a limited functionality to exchange the information with the coordinator. The ZB architecture consists of a APS, which is an application support sublayer, a ZB device object, which is called as ZDO, and the user defined applications. So there are two modes of communication in ZB, which is a beacon mode and one is a non-beacon mode. So this beacon mode is used to save power, and a non-beacon mode of exchanging the information via network. Example is a smoke detector. Okay, so here we are going to see the what is coordinator, what is end device, router, ZDC and ZB gateway. The coordinator is, as we have mentioned, the full function device and manages the whole network along with the management, and it starts the channel for network permits and the network to start and allows the other machines to join the network. And next one is the end device. The end device might be a reduced function device which has a minimal function and have a small transition time. This end device works on a joining of a network and leaving of a network. Next one is a router. As you all know, function of router, which is a full function device and mostly used in a mesh tree topologies, enhance the network coverage. And next one is a ZB trust center, ZTC. which is for security management, security key distribution, and device authentication. And final one is ZB gateway. The ZB gateway helps in connecting a ZB network with another network. So next we are going to see about layers of ZB technologies, which consist of application layer, network layer, physical layer, and media access control layer. This application layers is further has a sub layers, and this application sub layer, application framework, and then endpoints. This application sub layer has a responsibility to maintain the tables, in which the table consists of data used to enable matching and exchanging the information among the machines. At the time of discovery stage, the tables are availed by the device to recognize other machines that are operated in some area, or which is mostly the people get associated with the same area, which is called as a endpoint. The zero endpoint is a unique endpoint and contains ZB device object. This ZB device object ZDO explains the nature of device in a network, that whether it is a coordinator or a full function device, which is FDD, or reduced function device, RFD. Next one is a network layer accomplishes the network to grow, and this is capable of handling the network that has 64,000 nodes approx. The physical layer furnishes a high level of integration with the available of direct sequence technique, and also MAC, which is abbreviated as media access control, allows to form a many topologies without any complexity. And already you know a physical layer, which comprises of a ZB devices, and a media access control layer which controls the ZB devices. So as we already said, this ZB has some advantage, which is a ZB 3.0 consider the protocol which is designed to communicate data through a noisy RF environment also, that are common in a commercial and industrial market applications. So this ZB operates in a personal area network and also in a device to device networks, and also which is built on a existing ZB connectivity standard, but unifies the market specific application profiles to allow all the device to be wirelessly connected in a same network, irrespective of their market designation and function. It can be easily connected between the small packet of machines, and also it is used to control the lights, switches, and other appliances automatically. And also it is designed for a wireless control and sensors, and also it supports for multiple network topologies such as point to point, and also point to multi-point, and also mesh networks. And these also have a long battery life, low duty cycle, and also it has a it supports low latency, in which direct sequence spread spectrum will be supported, and it also has a 120-bit AES encryption for a secure data connection, and also collision avoidance, retires and acknowledgement. The software stacked incorporate a basic device that provide a consistent behavior or commissioning nodes on the device into a network. They are common of commissioning networks, which includes touch link, a method, and also proximity commissioning. So these are the ZB technologies which can able to handle the things. So next one is characteristics of ZB, which is a low in cost, and it prevents the problems like range and obstruction. It consumes a low power, and also it enhances the centralized security. So the centralized security employs a coordinator or trust center that forms a network and manages the allocation of a network and link security keys to the joining nodes. And also it has a distributed security, in which the method has no coordinator or trust center, and it is formed by a router. So this is decentralized forms by a router, and also centralized, which is employs a trust or coordinator, which is formed by a network. So these nodes adopt whichever the security method is used by the hub network they join. So it enhances the security also. This is also one of the characteristics, and also it has a protocol compatibility. The backward compatibility of ZB, which is a version is 3.0, means that applications and the smart home devices already developed under a ZB light link or home automation profile are ready for a ZB 3.0 version. This ZB smart energy profile is also compatible with ZB 3.0 and at the physical level, but smart energy has additional security requirements that are only addressed within the profile. So here, major applications of ZB technologies, which is of a which enables the broad-based wave deployment of wireless networks with a low-cost, low-power solutions. It provides the ability to run for years of inexpensive batteries for a host of monitoring and controlling the applications, and also it mainly used for developing a personal area network in a home automation and medical device data collection. Also, it is of a smart energy, smart grid form. AMR, which is called as automatic meter reading, lightning controls, building automation systems, tank monitoring, HVAC control, and also medical devices. ZB has a great application in projects that require a wireless connection. This technology has great use in low power digital radios nowadays, and this which is called as a DG ZB3 ZB technology, which is also called as XB3. So DG is a member of ZB Alliance and has developed a wide range of data networking solutions based on ZB protocol. So this DG XB3, you all note XBEE3, which is a latest in a long line of radio devices that provide a easy to implement solution that provides functionality to connect a wide variety of devices with robust connectivity standards. So this is a ZB technology about. Thank you.